Hello dear students. In today's class, we will try to understand the basics of moment of inertia. So we all know about the concept of inertia in linear motion. From the first law of Newton's motion, we know that when a body moves linearly, it actually experiences an inertia due to its mass. So the mass acts like a property of the body that actually opposes the motion or opposes the change in motion. So inertia can be understood as the property of the body which arises due to its mass that actually resists the change in motion. These concepts are actually dealt when we talk about linear motion. Just like that, in rotational motion, the property of the body that resists the change or that which acts like the inertia is often called the moment of inertia of the body. So I can say that moment of inertia is the rotational analog of mass. Just like mass resists the change of motion, linear motion, moment of inertia resists the change of rotational motion. So when you rotate a body, you will feel difficult to rotate it if its moment of inertia is higher. Similarly, to stop the body, you will feel the same kind of difficulty. So any change in the motion will be resisted by moment of inertia if it is a rotational motion and mass if it is a linear motion. So we can define moment of inertia as the rotational analog of linear inertia. So moment of inertia is the rotational analog of linear inertia. Linear inertia is nothing but the mass. It comes from the mass of the body. And how do we define moment of inertia of a particle? First, let us define moment of inertia of a single particle, and then we will enhance the definition to fit the moment of inertia of a rigid body. So suppose I am moving this point particle about an axis situated here. So I have tied a string to it and I am rotating it around this axis. And the particle moves in a circular motion. So the moment of inertia is defined as the mass of the particle multiplied by the perpendicular distance to the axis square. So this is R. R is the perpendicular distance from the axis towards this particle or the radius of the circular trajectory. So mr square is the moment of inertia of this small particle. So moment of inertia of a particle about an axis of rotation is given by the product of the mass of the particle and the square of the distance of the particle from the axis. So I is the notation for moment of inertia. I is equal to mr square. This is the expression for moment of inertia. So then what will be the SI unit of moment of inertia? Obviously, SI unit will be kilogram meter square. Kilogram for mass and meter square for radius square. So what will be the dimension of this moment of inertia? Try to find out the dimension of this moment of inertia. Now, having understood about the basics of moment of inertia and having defined the moment of inertia of a small particle, let us try to find out the moment of inertia of a rigid body. The rigid body consists of plenty of small particles. It is actually formed by small particles that are collected together and kept together. We define a rigid body as a body in which the relative position between different points or different particles does not change with time. So let us try to understand the moment of inertia of a rigid body. So suppose this is a rigid body with an arbitrary shape It is 3-dimensional, and we have to find the moment of inertia of this rigid body about this y1 axis. So this red colored axis is the axis of rotation. I am rotating it around this axis. To find the moment of inertia, we find out all the mass points inside this rigid body. So each point inside this body is actually causing the total moment of inertia of the rigid body. So I have plotted some sample points here. You can see an M1 here, M2 here, M3 is here, M4, M5, and Mn is here. Just like that, you have to plot and find all the mass points, all the particles inside this rigid body. Then the moment of inertia of the whole body, I, is equal to m1 r1 square, the moment of inertia of that first particle, plus the moment of inertia due to the second particle, and so on. And finally, the moment of inertia due to the final nth particle. So it is the sum of the moment of inertia due to each individual particle of masses m1, m2, etc. All the points that actually makes this rigid body have to be considered when you take the sum. So I can write simply moment of inertia I is equal to summation mi ri square. Summation over I, where I corresponds to the individual particle inside the system. So if I is equal to 1, you are taking the m1 particle, the first particle. If I is equal to 2, you are taking the second particle, and so on. Just like that, you have to count all the particles, take their moment of inertia, and have to find the sum to get the total moment of inertia of the whole system. So this is the concept of moment of inertia. I hope you have got the basic idea about moment of inertia of a rigid body. So try to understand the basic definitions, the moment of inertia of a point particle, its equation, the SI unit and dimension. And from that, try to understand how do we find the moment of inertia of a rigid body. The final answer is nothing but I is equal to summation mi ri square. I hope this topic is clear for you. Thank you.